Hello students, today we're going to be discussing about a very important derivation of chapter 1, which is electric field at a point on the axial line of the electric dipole. So here we have a dipole setup, which is a pair of equal and opposite charges which is separated by a finite distance to a. Now the half of the distance will be a, right? Now coming back to the axial line, this line here is nothing but your axial line. So if we extend this axial line till a point P, then the distance from P to the center of the dipole we consider to be R. Now if we were to find out the total length from minus Q to P, the distance will be R. Since this is the whole thing is the whole thing of this is R, we're left with A here, so it'll be R plus A. Likewise, if I want to find out the distance from just plus Q to P, if this whole thing is R, then we are considering only this half. We know that this is the distance for this is A, right? So it'll be nothing but R minus A will give me the distance from plus Q to P. Is this clear? Now coming back to, we're supposed to find the electric field at this point, at point P. Now because since we want to find the electric field at point P, we'll be considering a test charge here. We'll be considering a test charge here, a positive test charge here to be present, Q naught. We'll assume that the positive test charge to be Q naught. Now we're supposed to find the electric field at point P, and we'll be considering an imaginary test charge here. And we know that test charge is normally positive in nature. Now because of plus Q and Q naught, so if we look at plus Q and Q naught being both positive in nature, it will be experiencing a repulsive force, right? That is why the electric field will be in the right hand side, which we denoted with E plus Q, electric field due to plus Q charge. Likewise, because of minus Q charge and Q naught being positive, negative and positive attract each other, right? So the electric field lines will be formed on the left hand side, which we will denote it with which we will denote it with E minus Q. All right. Now if you look at the two lines, the E plus Q and E minus Q electric field, we see that plus Q is quite closer to Q naught. That is why we're seeing a heavier electric field, a more intense electric field as compared to minus Q. If you look at minus Q and Q naught, it is quite far away from our test charge Q naught. That is why it is experiencing a weaker electric field. So the magnitude of electric fields E plus Q and E minus Q at point P can be given by E plus Q is equal to 1 by 4 pi epsilon naught Q divided by the distance of plus Q to point P is R minus A. So R minus A square, equation number 1. Likewise, if we had to write down E for minus Q, it is 1 by 4 pi epsilon naught Q divided by R plus A square, which is equation number 2. Now if we look at this, both E plus Q and E minus Q is in the same but opposite direction. What we can write from here is E axial can be written as E plus Q minus E minus Q, since they are equal and in opposite directions. So now we will be substituting the value of E plus Q and E minus Q in this equation, which will give us 1 by 4 pi epsilon naught Q divided by R minus A square minus 1 by 4 pi epsilon naught Q R plus A square. Now we will take out common from here. Q and 4 pi epsilon naught is common, so we will take that out, and inside our bracket we'll be left with 1 by R minus a square minus of 1 by r plus a square. So when we rearrange this, we'll be getting an equation 4 pi epsilon naught r plus a square minus r minus a square, and the denominator would be r square minus a square of square. Alright, now so this is basically a plus b square, right? So we will decode this equation and we'll be having q 4 pi epsilon naught r square plus e square plus 2ar minus a square minus r square plus 2ar divided by r square minus a square to the whole square. Now what can we cancel from here? Minus plus r square minus a square plus a square. So when we cancel that out, we're left with an equation which looks something like q divided by 4 pi epsilon naught 2ar plus 2ar is 4ar divided by r square minus a square of to the power square. Now we know that dipole moment P vector is equal to 2aq. So we will substitute this value in this equation. So we'll continue with 4 can be written as 2 into 2, right? So 1, 2 can pair up with a and q, right? So we can have 2aq and other 2 with the r. So we have 2r divided by 4 pi epsilon naught r square minus a square to the whole square. Alright. Now we know a axial is equal to, we know 2aq, the value of 2aq is p, right? So we'll just substitute that in this equation. 2pr divided by 4 pi epsilon naught r square minus a square to the whole square. We can finish our equation here, or we can also proceed with a case when a is very small than r. In that case, we can neglect the value of a. So our equation E axial will look something like E axial is equal to 2pr divided by 4 pi epsilon naught. We will be having r to the power 4. Since a is neglected, r and r gets cancelled, we're left with r cubed. So this is the final equation. E axial is equal to 2p divided by 4 pi epsilon naught. We can also write it as 1 by 4 pi epsilon naught 2p divided by r cubed.